Okay, we're going to look at question 25. So in 25, 5 students dissolve this indigestion tablet, and an indigestion tablet will actually contain a base, right? Because your stomach is acidic, so you will use a base to help your stomach and in the water. And then they titrated their solutions, which is the indigestion tablet. So 25 cm³ of their solutions. This is the base or the alkali. With acid from the burette. So this is very important that the acid comes from the burette, and the indicator is the same. So the values you can see is all around 20.5, and then suddenly number 5 we use 22, and this 22 we should write down so that you will always remember. This is HCl. That means I added more HCl than I expected. Okay, so let's think about it again. So I have my burette, this is the HCl, and then I always use inside here, this is my base, and in this last experiment I used more HCl than I expected. So let's see which of these actions will lead to more HCl being used. So let's look at option A. The burette was washed out with hydrochloric acid. What does wash out with hydrochloric acid mean? It means that before the experiment, I took the burette and I wash it one time with hydrochloric acid. That means I wash it and then throw it away, and then I fill it up with hydrochloric acid. So will that lead to any changes in the hydrochloric acid? No, because I wash it with hydrochloric acid, then I use hydrochloric acid, so everything remains the same. So it will not lead to suddenly more HCl being needed. Next, the pipette was washed with distilled water. So the pipette is the one that puts in the base. Okay, so the pipette put in the base. Now this is a wrong step. We all know that the pipette shouldn't be washed with distilled water. So let's see what happens. If I wash the pipette with distilled water, means that the pipette might have some distilled water left inside. If some of the pipette has some distilled water, the base that goes in will become more diluted, right? Because there's some water left. So when I take out the base from the main, so it's here, I got the main solution. This is my main base. And then if I take the pipette and go here, but in my pipette add in a little bit of water, this will become more diluted. So that means lower concentration. That means lesser, right? Lesser amount of base. Right, so if I wash my pipette with distilled water, which is what I'm not supposed to do, I have some water, and then this one become more diluted. So will I need more or less HCl? I'll need less HCl because this one become more diluted. So this one is also wrong. Next one, the conical flask was washed out with distilled water. Now we all know, because when we do titration, we are supposed to wash the conical flask with distilled water. The reason why washing with distilled water is fine is because if I wash with water, and even if there's water inside here, the pipette is still okay. So the pipette will still transfer for this one exactly 25, right? Initially, if the pipette has water, it's not going to transfer 25, it's going to transfer less than 25 because already got some water inside already. So even if I wash the conical flask with water, the pipette will still bring in 25 cm³ of the base. So HCl still the same. Okay, last one, conical flask washed with tablet solution. So that means now what is going to happen is that, imagine we have the original solution inside the container, right? I have my conical flask, and then I washed it with some of the tablet solution. I don't know why he did that. You're not supposed to do that, but he washed it. So maybe I left some tablet solution. Then, will I know how much tablet solution inside here? No. I will still take my pipette and transfer 25 cm³. But this 25 cm³ is 25 cm³ plus the droplets of tablet solution that's left behind. So that means now I'll have a lot more base than usual. And when that happens, the HCl used will be a lot more. So that's why if I wash the conical flask with tablet solution, the volume of solution HCl needed will increase by a lot. Right? So when that happens, that's why this will result in 22 cm³ of titration value. Okay, so the answer for this is D. So please remember, never wash your conical flask with anything else besides distilled water. Okay, next one. Question 26. 0.1 moles of phosphoric acid is mixed with 0.1 mole per dm³ of sodium hydroxide, right? And I want to find which one greatest mass of phosphoric acid. And I'm given volume of phosphoric acid and volume of sodium hydroxide. So you might think that this is a CNV question, which is true. It's a CNV because I have a concentration here and I have volume here, so I need the CNV. However, you must also notice that there are two. Both this one and this one is given. So that means it's not only a CNV, it is also a have need have, a limiting reagent tile question. So what you can do first is that, because in order to use a have need have table, I need to convert the volume to number of moles. So I'm going to convert the number of moles. So let's look at A. So I have 10, so volume is 10 divided by 1000. Concentration, given the question, 0.1. So C equals to N over V, N equals to C times V. So I believe this is calculator. 10 divided by 1000 times 0.1 is, this one is 0.001 mole. Okay, so now you will need to go and calculate the moles for everything. So I'm going to just do it, but please pause the video here to make sure that you calculated all the moles over here. So this is 0.003. Please know that you need to do at least all this amount of work. Multiple choice is not supposed to require you to do lesser work. Multiple choice is supposed to require you to do more work because they are giving you options. So they expect you to be able to think, hey, my math correct or not? Oh yes, correct. Okay, so 0.003, 0.002. Okay, so we're going to use the have, need, have table. So let's start with option A. So this is option A. So option A, I have this. I'm only interested in this one. So have, need, have. So this is 0.001. If I have 0.001 moles, I will need 0.003 moles because the ratio is 1:3. However, I have 0.003. So I realize that I have exactly so I have enough. So I will use this and I do mole ratio and I know that I will form 0.001 mole. So for option A, I will form 0.001 mole. Okay, now I need to calculate for option B. You need to calculate it one by one. Okay, please don't be lazy. So have, need, have. So option B, I have 0.002 moles. So therefore by mole ratio, I need 0.006 moles. But I only have 0.002 moles. So therefore it shows that the sodium hydroxide again is limiting. So I use this for my mole ratio. And therefore this one over here is 0.002 divided by 3. So 0.002 divided by 3. Remember, there's no fraction, please. 0.667. So already, the question says which one formed the greatest mass. So far, A is in the lead. Right? So far, A is in the lead. Let's do C. So C, again, calculate, have, need, have. I have 0.003. So based on mole ratio, I need 0.009. But I have 0.001. So again, not enough. So I box the one that I don't have enough because I need you for calculation. So the mole ratio is 3:1. So this one is 0.000333 moles. Right? Divide by 3. So far again, A is still the winner. Okay, let's look at D. So D, have, need, have, you need to do this, okay? Please don't take any shortcuts. I have, and then based on mole ratio, I need, and I need, but I only have 0.02, right? So I highlight, this is the one that I don't have enough, so I do my calculation. So that's again 0.02 divided by 3, which is the same as this answer, right? Same as this answer. These two answers are the same, so therefore A is the ultimate winner. Answer is A. Okay, you need to put in the work. Alright, you need to put in the work. This is question 26. Next, question 31. Which reagents can be used to prepare a solution of copper 2 sulfate as the only salt? So this is actually a very straightforward question. It's on salt preparation. Salt preparation, I want to form copper 2 sulfate. You know that once I know what's the salt, I need to know what type. So this one, you must know that it's soluble non-spar. And once I know that it's soluble non-spar, I need to know that this is the add access method. And I know that the add access method, I need to either use my MAC, either my metal, my oxide, right, or my carbonate, and react it with an acid. So let's look at all this. Which acid do I need to use? I need to use sulfuric acid. So anything without sulfuric acid, I cannot use. So it's either option B or option D, and I need to know that it must be an acid reaction. So it must be an M, A, or C. But look at this, copper 2 chloride, even though this is C, but it's not a carbonate. So it cannot be copper 2 chloride with sulfuric acid because there's no reaction. So it must be either a metal, an oxide, or a carbonate. So therefore the answer is D. It's a very straightforward question. So please go and study this. Alright, next, 34. 34, I suspect that going down group 1, you know that going down group 1, which one is true? This should be a straightforward question, but I think there's a word that you all don't understand. So first one, number of electrons in valence shell increases. That's wrong because it always remains the same as at 1 electron. Melting and boiling point increase. That is false because you all must know that going down group 1, boiling point decreases. Reactivity decreases. That's wrong because you all should know that going down group 1, reactivity increases. So then we come to the point about metallic character. Metallic character, I hope you write it down, is the ability to lose electrons. So the ability to lose electrons increases down group 1. That is true because the ability to lose electron, if I can lose it faster, I am more reactive. So therefore the answer here is D. And the last question we're going to go through, 35, which one is most true for astatine? So astatine is right at the bottom, right at the bottom under iodine, and then we got astatine. So we know that iodine is a black solid. So it is not possible that astatine is a black liquid because when I go from a gas at the top to a solid, astatine has to be a gas, a solid. So this is definitely wrong. Next, astatine reacts with hydrogen to form a compound HAT2. So let me ask myself, if hydrogen reacts with chlorine, do I form HCl2? Right? This sounds ridiculous because HCl2 cannot be formed. Hydrogen can only form one bond, Cl can only form one bond, so it must be HCl. Okay, so HCl. So this one is wrong. It must be HAT. Next one, potassium acetate reacts with chlorine gas to form astatine. So chlorine, which is here, is more reactive than astatine. So chlorine can displace astatine. Next one, potassium acetate reacts with silver nitrate to produce aqueous silver acetate. So let's think about it. Potassium chloride, which is in the same group, reacts with silver nitrate to form aqueous silver chloride. So we all know that that is false because chloride SML, right? Silver chloride is insoluble in water, so it cannot form an aqueous solution. So silver chloride is insoluble, means that silver bromide is insoluble, means that silver fluoride is insoluble, means that silver iodide is also insoluble, means that silver acetate is also insoluble. So the problem with here is that it cannot be aqueous. Silver acetate is a insoluble solid. So therefore, the only one that is correct, that is most likely to be true, is C, that the displacement